My name is Oleh Dokuka. I work for Netify. I'm doing reactive programming since, I guess, the initial initial starting of creating reverse reactive Spring and Reactor. And today with me is one of the developers, advocate, and amazing speaker, Mark Heckler, who is working for Pivotal and doing advocating of reactive as well. And today with me, my colleague, Igor. I guess he is well-known as well person. And first of all, I'd like to ask you, do you know what is BoF? Any idea? Right. So, can you explain maybe what should we do at this part of session? Right. So, first of all, BoF's birds of face is kind of free conversation between speakers and the audience. So during this conversation, you can ask anything, of course, related to the main topic, kind of reactive programming, reactive streams, Reactor, Spring, reactive Spring with Flux, whatever you want. And we will discuss that. Is it clear for now? Okay.
Or if you have particular observations that you want to throw out from your use of any reactive library, but of course, primarily Project Reactor, right? But if you have any observations or comments or what have you, just throw those out as well. So.
Yeah, so this is basically free conversation between us. And would you like to add maybe something?
So do you have any questions already? Your hands. I wanna see your hands. We wanna help you to ask questions for our guests because I and Oleh are often at Lviv and Mark is not so often. So
yeah.
But he said he'll be more often here. So do you have any questions?
Okay. So I guess
let's
start with the simplest one. Can someone explain your understanding of the word reactive? Do you have any idea of what reactive means for you? Come on, guys. Huh? Okay, so one of the options is non-blocking programming.
Who has any ideas about that? Who of you have ever tried to build a reactive application? Okay. Who of you have never heard about it at all? So, and what's doing the rest of the audience? Are you developers at all? Okay, so it's all joke. So yeah, it's about non-blocking. What else? What do you want to know about it? What's what's your point of being here? What's your interest in that area? Do you have any? Or we may just go to drink some water, beer, and tea.
All right, let's start.
Okay, cool.
So, could you please tell all of us, probably you face some issues with reactive in your practice, and what are they? How did you solve them? And what is the best practice to avoid them?
Well, I will start this hot potato. What do you do, Oleh, when it comes to debugging? It's a setup.
Okay, so when I came to debugging, I usually go through the whole reactive hell, counting the internals of Reactor, and I'm thinking what is going on there. Of course, I know how it works, so it's probably easy for me to start debugging and understanding what is going on. But usually, I'm going through the hell of all this stuff. Then I realize that I can enable some internals features like an operator debug or something like that, and start analyzing stack trace or something like that. But yeah, when it came to debugging, I usually try to avoid it because debugging in reactive programming is really challenging stuff.
I'll throw back in because I don't want to be unfair because he's absolutely got this, but it's a different mindset and a different model, right? Because when you're dealing with a single thread, you can get that nice, easily followed stack trace. But with the reactive model, you have a scheduler that will be hopping, your particular request may be hopping across several threads. A small number, but still it's crossing threads. So crossing streams, crossing threads. So you lose some information that way. So it makes it a lot harder to debug. There are tools that you have at your disposal, like hooks.onOperator debug, but those aren't without performance penalties, right? So there are certain things that you will not want to do, which is just turn on debugging for everything all the time. But you do have options like checkpoints and light checkpoints, which allow you to maybe trace in, well, I shouldn't say that word. It allows you to isolate and where problems may be occurring a little bit more tightly, and then enable debugging specifically for those areas that you need to chase to ground. So it's a different mindset. You lose that, I guess, more clear mechanism for following through where things break and the call stack that got you there. But you gain so many other things in terms of scalability and benefits that even though that increases the difficulty in one area, it's still for those requirements that require a lot of scaling with, again, minimizing resource utilization, you gain enough that I think it's worth the pain. Yes? No?
Yeah. Yes, this is one of the painful sides of reactive.
So debugging is definitely a problem with reactive programming. Shall we continue with questions, or kind of?
Is it, first of all, is it answer to your question?
I just answer about the general things. It probably is a list of things. Is it only debugging and that's it?
First of all, I guess.
Let me answer.
Yeah.
Kind of. It would be a really long conversation if we just try to go through the list of problems. And actually, I did such a presentation last year at GConf. It actually in 1 hour long conversation about list of problems, and there are lots of them. But as Mark said, there are lots of benefits also. So debugging is first one. You need to understand this different paradigm. It's not imperative paradigm anymore. You have notion of time in your API. This is kind of something completely new for us who came from imperative programming. So previously we just made a request and kind of returned response. And now we may say that we receive that response in chunks or kind of in as a collection, but one by one. And even time of arriving elements in that collection matters. So it's a really long story with what problems you may face, but probably if you will talk today kind of from this kind of about each of that problem, you won't like to use reactive programming at all. But libraries, current generation of reactive libraries like Reactor, Rx Java 2 has a lot of instruments to overcome most of the problems, but one. I would say that it's mindset. So if your mindset is not ready for reactive programming, for non-blocking, for asynchronous, and probably for immutability, if you don't like immutability, it would be hard. Otherwise, it's not so different from the stream processing.
And just to throw in one other thing, today is the absolute worst tooling we'll have from this point forward for any of the reactive constructs that we're talking about, because tooling, necessarily lags innovation. So even though we've had RxJava in one iteration or another for several years, it just takes time for everything to kind of catch up. So over time, of course, better and better tools, better and better constructs come in for dealing with that. So this is the worst it's going to be moving forward. It's just getting better. So yeah.
Thank you. So I think I have a very basic question. On the application design, and when you see the requirements, when you see that it is a good approach to use reactive approach in your application, like basic patterns, basic requirements, like number of clients in 1 second or something like that. Thanks.
Well, I'll throw out a contrarian perspective here first, and then let these two tell me I'm wrong. I like to do that. But I typically don't look at brownfield applications that are already in production, that are scaling well, that are handling things well. I don't see a compelling reason to go and retool everything. Because if what you're doing works now, you're not seeing any kind of crazy spikes in scaling out and in, and everything's humming along, probably you're not going to be changing that. Now, over time, of course, as more and more potentially, potential systems come online, applications come online that address these crazy scaling requirements, that provide more capabilities, more scalability for smaller resources, you're going to see, I think, this natural transition where you're going to have more and more systems that are exposing reactive interfaces, and they're still having to deal with these blocking interfaces, and that may at that point become worthwhile to start converting some of those. But I don't see a compelling reason to just stop the world, retool everything using a reactive model, and then start it back up again. I mean, we have systems that are working that are bringing in revenue for all of our companies. We don't want to see those stop, right? Because otherwise we're out of a job. But I think if you look at your requirements list, the dream sheets, the wishes that customers or end users have thrown out, man, if we could just have this system, we need this particular functionality, and you go, wow, we don't have the tools to provide that capability, we can't anticipate scaling. This is a perfect example of a fit for that, a solution for that. And maybe you haven't had those tools at your disposal before, but now you do. Now you can start bringing some of those problematic solutions that had been problematic online. So I look at this as more of an area that you can start building out some of these and providing solutions to problems you haven't been able to solve well, and then over time start migrating and converting, not before.
Yeah, it's absolutely correct. Regarding, I guess, the patterns that could be used there in reactive, I guess, place is like when you see streaming, like when you see a pipe of changing of some events, and if you have some infinitive, maybe a dynamic source of data, then it's probably a good place for reactive programming, because with reactive programming you can naturally build a pipeline of transformations of your events through not only through one service but through many microservices, and this will be naturally fits the overall paradigm. This is one of the screaming maybe places when you should use reactive programming, because with imperative programming it will be a little bit harder to understand what is going on in the whole pipeline of your transformation. So reactive programming simplifies that a lot.
At one point, some kind of additional pattern. I saw that reactive programming could fit well. Have you ever tried to write a high-load service, something like a high-load HTTP service based on netty? No? So if you want to do a very highly efficient service, you won't be able to use blocking calls like a blocking server like a Tomcat or Jetty. Most likely we will go with netty, and using netty with its native API is very, very problematic. You should use non-blocking kind of new EO, non-blocking EO that is pretty old in Java. Have you tried it? Yeah, so I see one person. So it's API that allows you to communicate with network or files without blocking a thread. And using that API natively is kind of horrible experience. And reactive programming fits well as an adapter over that API to have a very cool, high-level, still very efficient API to work with network and files in very, very efficient way. So we did a test, and such solution based on Spring Webflux, it's at least twice or 3 times better than the solution based on the blocking Tomcat approach.
Yeah, it's worth to know that this is improvements in performance in throughput of the application.
Yeah, so you won't process requests faster, but you will be able to process more of them at the same time. And probably I would say one anti-pattern where not to use reactive programming at the current moment if you have simple CRUD application. So you have Oracle database and you're just doing putting data from REST endpoint to the database and back again. And that's what's your application doing, nothing else. And not because reactive programming does not fit CRUD, just because do not have a well-established ecosystem for reactive drivers for databases. However, I won't touch a lot this topic because it's a topic of our next presentation that will start in half an hour. So kind of.
All right. Let's see the next question.
Yeah, I probably have a question about the next topic, but still. So, what would be the benefit moving to reactive if you still have a blocking data layer? So, yep.
Well, much less. And I'll expand on that a little bit. Traditionally, our Spring Data team has been very, well, they frankly refuse to support any database that doesn't have a reactive driver, or at least an asynchronous driver that you can work with. Because it doesn't do a lot of good if you build out a reactive application and then block when you're storing and retrieving data. There are ways to get around that, but then you're dealing with buffering and things that introduce a lot of complexity. And you're introducing some complexity anyway with reactive programming, as we've mentioned with the debugging and tracing and what have you. So it makes very little sense to add complexity and gain perhaps nothing. So that's why with Spring Data K on up, we've supported 4 databases: Redis, Couchbase, Cassandra, and Mongo, because they have a mechanism in place, a driver that will allow us to not block, right? With R2DBC, because the next question people always ask is, well, I'm using Oracle or I'm using MySQL. What do I have in terms of options for interacting reactively with my database? And Oracle 2 or 3 years ago came out with the statement that they were going to be producing ADBA, the Asynchronous Database Access, I think it stands for. I'm terrible with acronyms. But they dropped that news and then did nothing for quite a while. And over time, there were several folks who said, you know, we really should get this ball rolling, and we're tired of waiting. So we kind of kicked off an effort along with several other folks, several other organizations called R2DBC. If you go to the letter R and the number 2, and then dbc.io, that you can start taking a look at what we have. You can dig into the GitHub repos. You can start coding. You can submit PRs. You can contribute code. And we're working through different database support access, I guess, packaging. Because we've got Postgres. We've got a guy who's working on the Postgres stuff. We have MySQL coming online. MS SQL, I think, is in there too, last I checked. And H2, Greg is working on that. And I did a video about this several months ago that I threw out, just kind of like getting your feet wet with it. Josh also, my colleague Josh Long, has also done a video on that, taking it a little bit further. But it's very easy to get up and running, but it's very early days. So your support for any particular database is rather limited at this point. But it's a roadmap ahead. Now, the next question people often ask is, if Oracle actually does get the ADBA effort going and it seems to grab industry support, what then? And R2DBC is able to leverage and we will work with ADBA to implement using that as well. So anyway, that's my start on it, wherever.
I can add a little bit on answering the question whether it works to start using reactive programming when you have blocking database. I'd like to cite one person. I don't remember whether it's Victor Klang or Roland Kahn, but one of those persons say that you can get some benefits of using reactive programming with blocking database. You can provide, usually we use with database we kind of couple the notion of connection pool to database with the notion of the database. So we can use or provide additional thread pool around our database and provide a thread for each connection that will serve every request to that database. But of course you will get some benefits by doing that, but if your database is a bottleneck to your application, any reactive programming, any resolutions of optimizations in programming or programming paradigm won't solve your problem, because database will be the bottleneck of your application. And if you add, even if you add some non-blocking communication on top of that, it won't solve your whole problem.
But it might look prettier from the outside.
Right.
So yeah, Mark just told the whole kind of.
Come on, he spoiled a lot of our.
He spoiled almost everything that we are going to take on the next presentation. So.
I'm so sad. I'm so sorry.
No worries.
So, do you have any questions? Hands? Yeah, I see one.
Hi, Mark. Thank you for your presentation. I actually have a question regarding to those 3 services that you wrote for us.
Yeah.
And as I noticed, that, there was no registration of endpoints. So how does those services find each other? There is some service discovery, or how does it work?
No, actually, and I feel like I can safely answer this without messing up anything else, so I will. Yeah, because everything was communicating over, in my case, I was running Rabbit in the background. So by simply pointing to a particular exchange/queue in Rabbit, and that's why in the properties that I was pointing from the source, for instance, I said the output, destination and group, or processor, because I defined a group, an exchange/queue called processor, that then my processor was looking at that for the input. So that's, with Spring Boot's auto configuration, it provides the necessary connectors and necessary beans, I should say, because the connectors are actually provided by Spring integration. But by pointing it to the output destination from my source, the same exchange/topic that I was then using as my input destination and group from my processor, one would feed the pipe, one would pull from the pipe, or listen for the values coming down the pipe, I guess is the more proper way to say it. So yeah, everything automatically connects at that point just because you specified the group and the destination.
Yeah, okay, thank you. And
sure.
Maybe a second question, it's regarding to testing. How do we test? Best approach to test such applications when we have working with queues with asynchronous messaging?
Several levels you can do that. I mean, you can mock certain things, but then if you actually need to do the full integration testing, you're going to have, I guess the best way I know is to, well, have a limited test environment where you spin up the services and then you monitor what comes down across the console, for instance. Personally, what I like to do to troubleshoot and try to diagnose any weird issues that I'm seeing is to pull up the Rabbit console. And I use Rabbit primarily, but obviously, your mileage varies if you're using Kafka or something else. But that's at least a starting point.
Yeah, actually, if we focus on reactive programming in general, there is some tools that allows you, built-in tools in, for example, Reactor or RxJava, that allows you to test your flow really easy with defining some verification step and expectation what will come at such point in time and so forth and so this also could simplify your verification of the flow. On the other hand, I know that there is a lot of built-in tools in Spring that allows you to test the same like streams, counting like cloud streams and so forth and so on. So you can use Spring as a source of some tooling for that, testing for that. Sorry, tooling for testing. What else? Maybe you have some.
No, I would say that we have time for one question or maybe two, if it would be short. So, do you have any? Yeah, I see.
Hello guys, I have a question. If we already have an application running on, I guess, Tomcat and it's blocking, can we mix approaches, reactive and traditional? So maybe we have one Mongo repository that is reactive and the other is blocking and something like that. Thank you.
I must say shortly that nowadays not a one good application server or HTTP server is actually blocking. They have non-blocking API underneath, so Tomcat is also non-blocking, and kind of you may use it in different ways in different parts of application. However, it would be not so easy to do with current Spring stack. So you will probably need to choose whether you're using Webflux or Spring Web MVC. I guess you may try to mess up with different application contexts, starting kind of a different part of application on different ports, but probably it's not what you want. You may still use Webflux with the old annotations or old approaches. If it doesn't block inside, it will be still efficient, and you may still use Tomcat for reactive application. However, it's not as seamless integration as you could imagine.
I understood your question differently. So if I'm out in left field, I'll apologize in advance. But are you talking about using different applications and communicating, or are you talking about within?
I'm talking about one application, but slowly migrating to React.
Ah, okay, okay.
Half of the application is blocking and half reactive.
Oh, I see what you're saying. Okay.
It's possible.
Well, let me, yeah, I was going to say, let me just throw this out then. Are you familiar with REST template?
Yeah.
So REST template has kind of been the Swiss Army knife for for blocking API calls, right? Web client is the mechanism that we're kind of, how do I say this? That we're investing our time and energy into going forward, because web client is reactive, but it can also deal with blocking calls as well. So I mentioned this earlier. It's very easy to go from a non-blocking to a blocking call, or return an actual type versus a reactive type. It's not so easy going the other way, because then you have to deal with buffering and things like that. So web client, actually, if you're dealing with all the reactive types, you're dealing with fluxes and monos, but at some point you need to be able to return an object of type T or interact with another service that's exposing just a blocking endpoint. That's very easily done. So I would start, my perspective is, if you're looking for a way to kind of get started without like having to look for a rafter to hang yourself from, convert your REST template calls to a web client. And don't change anything, just change that. Everything's still blocking. But then over time, as you start to replace your blocking calls with non-blocking calls, that's much more easily done at that point. You've already kind of pre-positioned.
So yeah, you may kind of migrate internal, then try to switch to Webflux with using the Tomcat. It's still kind of Tomcat, however, it's using better approach for handling of threads. And then, if you wish, you may throw away Tomcat and use Netty and gain a little bit more of raw performance, if you wish. It's slow process, but it's possible. It's really possible. So it's not either or. You may still go that road. And we have 5 minutes for questions. Oleh? Yep.
So you mentioned Netty, but as I know, modern serverless containers, they already use Neo under the hood. at least I know Tomcat had this Neo connector a long time ago. So what would be a benefit from switching? At least how net is better than these serverless containers, Neo-based. So thanks.
You want to start us off?
Okay, so in short, Tomcat was built as a server container from the beginning, and it's kind of what it was designed for. Later on, they the team improved internals, and now it supports non-blocking API. Also, we should say that servlets itself are, at least from versions 3.0 or 3.1, are could be non-blocking. However, netty, it's not a servlet container. It was built from the scratch to be as fast as possible, as efficient as possible, and netty do not need to be compliant with all that servlet stuff. That's why it's a little bit better. However, if you compare configured Tomcat based on Neo approach and netty, you won't see so huge difference as between netty non-blocking and Tomcat blocking approach. So it's just kind of your choice at that moment. What do you like more?
I'd like to add a couple of points to Igor's answer. First of all, netty uses entirely coupled with the notion of this flyweight pattern, which means that inside of netty there is a pool of buffers, or there is an allocated pool of memory for all incoming requests and written response. And netty built on top of the flyweight pattern, and netty under the hood reuse all the buffers that's in this pool, and netty use some notion of ref counting and so forth and so. First of all, netty doesn't create new reference, and this means that if netty doesn't create new reference, it doesn't give more work for garbage collector, which means that netty will be much faster than the same Tomcat. I'm not sure that which approaches is used in Tomcat, but the main, from my point of view, the main advantage of netty is that it uses like kind of ref counting and flyweight pattern, which allows you to decrease the number of created objects in your application.
Also, as far as I remember, netty has some modules that allow you to kind of hook to the native code of the Linux itself and gain some benefits from that tight integration with event loop of the operation system you use itself.
All right, so next question.
So guys, come on, we have a slot for one question.
All right, so if in case we don't have any more questions related to maybe non-block, I'd like to shift our conversation a little bit to the notion of, or to your understanding of reactive system. Like by that moment we have been talking about reactive programming, about non-blocking communication between the system, between the network and our Java code, let's call it. But what do you think, what is reactive system? What it means for you? Do you build reactive systems maybe at your company? Okay, then maybe someone have some ideas what is reactive system in general, what it means. I guess, yeah, the correct answer is more about reactive manifest and how you design your whole system. Maybe, have you ever heard about reactive manifesto before? Okay, a couple of hands, I see. So maybe you guys can explain what is, from your understanding, reactive system.
Well, I think we're almost out of time, so I will do like the 10-second spiel, and then I'll let Igor take, and we'll probably wrap up. But if you think of an application as not blocking throughout the consumption of an application and processing flows of values, if you will, within your application, reactive systems are continuing that in the integration points among various different applications as well.
Yeah, so kind of, I would add that reactive system is a system that survives demands of the wildness of all that crazy clients that kind of use your system, and system that brings your value brings your money. So if it's well suited for the needs of the current world, most likely it's already reactive. So thank you a lot for your attention. So we are still here for the rest of the day, so can feel free to grab us and talk about whatever you want. And in 10 minutes we want to start our next reactive topic. It's about reactive database access. So thank you.